Okay, so you guys know if we were to graph an equation like this, what would it look like? Okay, the shape though would be a line, and because the slope is positive, it would be going like up, right? And what happens if we make that front number a minus 2? The slope would be going down. Okay, and then what would the graph look like if I did one of these things, quadratic equation? What does it look like? Looks like a parabola. And if I put a negative on the front, it'll go down. Okay, so what do you think? What would you guess? Doesn't really matter what all these extra things are. If it's a cubic function. Don't get what?
Oh no, it's like.
Okay, if it's a cubic function, what would you guess it would look like? Okay, it's, yeah, one of these. So it's kind of like a parabola, but then it turns again. Squiggle, yes.
Oh, I get it.
It's like
Okay. So what do you think if I made the leading coefficient negative, what do you think that would do to it?
oh gosh. Make it do the other.
It would flip upside down. So it would go down, starting up, going down, and end down. So it's kind of up to down.
Endothermic. It's pretty thermal.
Okay.
Yeah, because you're pretty cool. You bring
Thermal just means temperature, doesn't mean hot.
the force of thermal.
Okay, so, girls be quiet. If we had like it's called a quartic function. That word's kind of rare though. All this other business out here doesn't really matter, so let's put dot, dot, dot. What do you think would happen if we had a quartic function, x to the fourth degree?
Okay, like 2 rounds again.
You're close, you're close. Yeah, it's a W.
Yeah.
Yeah,
Unless, if we make the leading coefficient negative,
it's 2 rounds.
yeah,
It's just an N.
it's an M.
No, it's 2 rounds. That's Montana. It's 2 rounds.
That's definitely an N.
Nope. Nope, but M's are pointy.
Mountains have points.
Okay.
No, they don't.
Okay, so
Right then, like that.
let's try one more.
Maybe I got things.
Oh.
Smart.
X to the fifth.
It's both. Sideways.
Too much.
Okay, it's a kind of a double squiggle.
It's
Do you guys see any patterns yet?
Yeah.
It's very squiggly every time.
The third one
It's
would
like
be
a
easy.
carol.
Okay, let's zoom out and see if we can see any patterns. Get that geometry over
The
there.
sixth one would be easy.
No, that's geometry.
Oh, I see that.
What shapes are those?
Those are
Parallel. Wait, no,
Trapezoid.
trapezoid.
Trapezoids.
I said
You're
first.
smart. Yeah.
Okay,
I said it first.
okay, hush, hush, hush. Do you guys notice any patterns here?
The more exponents you
Add
add,
more squiggles.
Hey, girls, you need to do that later. We're learning something right
For
now.
real.
What? Any patterns?
the more exponents you add, like another squiggle.
Okay, every time you add an exponent, you get another curve. That is something. Like this had, x squared had one curve, basically. X cubed had 2 curves. Curve, then curve again. Yeah, it does add another curve. Anything else you guys notice? Okay, one of the patterns is, so on the the normal y equals x to the 1, you could say, I guess. It goes down to up and up to down. On x squared, it goes up to up, or down to down. On x cubed, it goes down to up, or up to down. Up to up, down to down. You guys see where I'm going with this?
Are we gonna have to remember like how
kind of. Yeah, this is the easy stuff though. Well, you guys already knew these two, right? So just add a squiggle and like a W, that's not that bad. Okay, so the pattern is if there's an odd degree, 1, 3, 5, it goes down to up. Unless it's a negative, if the leading coefficient's negative, it switches up, it's upside down, so it goes up to down. Okay, but if there's an even degree, what happens? X squared, x to the fourth, what happens in this case? Goes from up to up, or if it's upside down, it goes down to down. So the fifth degree is more like the third degree than it is the fourth degree. So fifth degree, just add an extra curve. So the M kind of becomes that, whatever you want to call it, double squiggle maybe. So the fifth degree looks a lot like the third degree. See how they're pretty similar? Goes down to up. So the degree just means the polynomial's largest power. That kind of decides what shape it's going to take. The reason why it works, I don't know, maybe you don't necessarily need to know this, but if we plug a large negative into a cubic function, what's it going to spit out? If we plug a large negative value in for x to a cubic function, what's it spit out? Negative. So if you plug in a large negative, it spits out a negative. If you plug in a large positive, what's it spit out? Positive. So they move down to up. But if it's like fourth power and you plug in a large negative, what's it going to spit out? Positive. And if you plug in a large positive, what's it going to spit out? Positive. So that's why they move up to down. And because this exponent is a way strong, the degree, the largest power is a lot stronger than these. It kind of overpowers everything else that's happening over there. So really you just need the largest power, and then is the leading coefficient positive or negative? And that kind of decides everything for the shape. See, that's not so bad, is it? Let's take a peek.
Pete, that's an Attack on Titan character name.
That's the lamest name ever, bro.
It is Pete. Who named himself Hope?
Okay, like what?
Says Shannon, bro.
Who? Okay, well, Hope, that's so like basic.
You sound like a white person. Like when I was thinking of Hope,
You sound like a white person.
like someone told me
No,
that
white
there
people
was
are named
Hope.
Shannon. Like the
I was
average
like,
white woman.
What
is
white
named
woman
Shannon.
is in here?
So whenever I think of
white
Shannon,
woman
I
is
think
in
of
here?
white
Like,
woman.
Okay,
I was like,
alright,
oh,
jeez.
she's Asian.
Girls. Shannon, you are one to talk. I always ask your brothers, why do you have English names?
I have an
It's
Indian
Bible.
middle name.
Yeah, why aren't you
Yeah.
like, I don't know actually.
Yeah, exactly.
Literally.
Why aren't you Ruth?
Come on, Shannon.
Because they didn't want
What
like,
is an
people,
Indian
like,
name?
not to pronounce it right, I guess.
Her middle name is.
But didn't you
Summer-
get that name when you were born though?
Ravi.
Yeah.
Because your parents, did your parents,
Yes.
were you born in the U.S.?
Yeah.
Was Josh born in the U.S.? Okay.
About Jose.
Wait, no, but your grandpa's name was like
Oh, what's his name?
Alfred.
Alfred.
And he never came to the U.S.
I don't know.
Okay,
One of my
because
friends
I
laughed
talked to your
when
And then I
brothers.
had a baby.
they figured out their name
I
was
don't know how
Albert.
it's gonna have babies.
Oh, Bobby was
Because they
fine.
always remember they called it Mr. Kipling, and then it had babies, and they were just like, it's a woman.
They got captured. They got captured. Like, oh, it's a missus.
Okay,
Yeah.
Bertram. He looks like my dad.
number one.
I think it's Bushman's game.
For each function, state. Hush. Let's move on. Number one, what's the degree of the polynomial? 4. It just means the largest power. So, number one is 4. The second is, what's the leading coefficient? -1. That means the number on the front.
Where'd you get the 4 from?
The degree is the largest power. The leading coefficient is the number on the front, basically, and the function's in behavior. So what does negative x to the fourth look like?
It's down.
Yeah, it was like an n, right? So the in behavior is towards the ends of the function, like to the outside. It's going down and down. So yeah, that's what they want. They want down, down.
Down, is that right? Wait, what?
Okay, the function x to the fourth,
Oh,
but it's a negative x to the fourth, should look like this, right? Negative x to the fourth. I don't know where, yeah, right there. Anyways, so the in behavior is what's happening at the edges of the function. It's going down and down. Because x to the fourth, it's an even power. It's either going up, up, or down, down. Since it's a negative on the front, it's going to be going down, down.
On the odd exponents, if it's positive, they start up or
Down to up. Heading up, heading up. Number 3, what is the degree? 5. What is the leading coefficient? Really, the only important part about the leading coefficient is it positive or negative, because that tells you if the graph's going to be heading up or down. So if it's a 5th degree, what's it going to look like? From now? Well, sorry, it's negative. Yeah, you're right. So since it's negative, it's gonna, instead of going down to up, it's gonna be going up to down, something like that. So up, down. You guys hot or cold? Who knows?
Good question.
Do we want hot or cold? I feel fine.
Oh,
I'm chilling. No,
This is cold
I'm
air.
like right perfectly middle.
Yeah, I feel fine. This vent is closed, so if you guys are not, you can open it. I feel perfect. I feel just right. Goldilocks. Number 5.
Sorry guys, it was 3. It was like the 3 exponents.
Okay,
Oh, down, right?
number 5.
It's on this page. Oh.
Do we have to FOIL all those together? The answer is no. We don't have to do that. But how do we figure out what the coefficient or the degree is? Yeah,
You said it loud.
Oh, yeah, you would do,
kind of,
Oh.
but it depends on what you mean.
like I like 3 and 1.
Yeah.
You broke it down.
Yeah.
Okay. Do we have to multiply all these together to figure it out? No. What would if we did multiply them together, what would the front term have to be?
That's a great question. 3.
Okay. All these things, if you multiplied them together, would give you the leading term. So what's 3x cubed times x times x times x? 3x to the 6th. Okay, it doesn't matter what comes after that because there'll be a lot of stuff, but that problem will take forever. All we need is the front term. So if we did FOIL all these together, eventually we would get the biggest term, or the leading term would be 3x to the 6th. You guys get it? Because like if we FOILed the first two, the leading term would be 3x to the 4th, right? And if we multiplied that by this, the leading term would be 3x to the 5th. And if we multiplied it by this, it'd be 3x to the 6th. Okay, anyway, what's the degree of the polynomial? 6. What's the leading coefficient? 3. What's the end behavior going to be? Yeah, if it's an even, It's like it's gonna be the same thing as like a x squared. It's gonna be like a parabola, except for there's a lot of curves. But it will end just like a parabola. It'll end going up, up. Up, up, and away.
What about 6? Yeah.
Did I do number 6?
You should do 6.
Oh, I should do 6.
Please be kind. So
Alright, fine. Think you got it?
Probably.
Well, okay,
I was
if
talking about my mom like that, about that yesterday. Really? Yeah.
if x minus 8 is squared, that means there's like 2 of them, right? So, if we FOIL these two together, what would be the leading term? X. If we FOIL these two together, what would be the leading term be? X squared. Okay, and then if we took x squared times this, what would be the largest term, or the first term? Okay, negative x cubed, because there's a negative on that x. So x times negative x basically is negative x cubed would be the leading term. I'll stop there now that I did the tricky part.
Can you do the 40?
Okay,
No, I didn't write that part.
No.
Just,
I read
just
that
flush
most of
it
it,
out.
I just forgot the down part. It's alpha. It's alpha, thank you.
Oh my gosh, this is so stupid.
That's gonna be one of those stupid things.
I don't know, I love that everything's the same.
alright, number 7.
It's just better than
For each graph, okay, the last 6 are kind of hard. The last 6 are like yesterday's last 8, so a little bit trickier though. Number 7, for each graph, state the number of real zeros, the functions in behavior, that's the easy part, and whether the function degree is even or odd. Okay, so we've talked about this before. What are the zeros of the function?
3.
It's the x values that make the function equal 0. On the graph, however, the zeros of the function are the x-intercepts. So maybe this x-intercept is 3, 0. So 3 would be one of the zeros of the function. Maybe negative 0.5 or negative 3, whatever. On the graph, where it crosses the x-axis, these are the zeros of the function because these are the values that make the function equal 0. So the first question on 7 is, how many zeros of the function are there? 3, because it crosses the x-axis 3 times. What's the function? I don't know why they asked this because they show it in the picture, but what's the functions in behavior? Up, down. Okay, we'll give you guys some free points there. Does everybody understand what they mean by in behavior? Somebody might be confused on that. Whether is the function's degree going to be even or odd? Odd. If it alternates from up to down or down to up, that's an odd. That's why they ask, because the next question is even or odd. It would be a cubic function, right? Number 7, because anyway, it's x to the 3rd function. Okay, number 9. How many real zeros does number 9 have? How many times does it cross the x-axis? 4. In behavior on 9. Down, down. So must that have an even or odd degree? Even. Okay, 11 through 16 is what we did yesterday, except for some of the answers are not nice, neat numbers. They're like square root answers. But they're telling us in the directions to round those answers to the hundredths place. So we're going to have to use our calculator and maybe hit the decimal button to finish these off. But actually 11 and 12 are nice, neat answers, kind of like yesterday's. Anyway, so it's a repeat of yesterday. So we have, how are we doing on time? I might be nice to you guys because you're in front of the other class now, but I don't know how to handle it. Kind of like half a day.
This is the entire assignment, 1 through 10.
No, I do want you guys to do the hard ones.
Why don't we do like a worksheet tomorrow? Again? Oh my gosh, I can't. Dude, I can't. It's not funny.
Okay, we'll keep the assignment the same, and yeah, I maybe give you an easy worksheet on Monday or something. Something that we haven't done in a while.
Addition.
Oh, we haven't done that.
What are we
Oh,
going
yeah,
to?
please, I
No, I meant from this chapter, no.
So we're going to 16.
Like addition or
Yeah.
adjustments,
If it takes too long, I might like give you like the easy worksheet plus a couple problems that we didn't do. It's the same as yesterday. I don't think we'll have too much trouble. Okay, so actually number 11 is a little bit tricky because what's our, you guys remember how to find the possible rational roots? Okay, factors of this over factors of that. So what's the factors of this going to be? Okay, this is where it's kind of a trick question. We're missing a term out here.
plus 0.
So it's factors of 0 over factors of 1. So what are the factors of 0? Well, yeah, it's kind of like 0 in anything.
So it's like anything.
Yeah. I think they meant for us to factor this first one. It doesn't really say. This is the only one quite that's like this though. Oh, 13 is kind of the same. Yeah.
And 14.
Oh, is 14 too?
And 16.
Yeah. Okay, well, let's think of this in fact. We could have done that, but let's think of this in factoring terms. How could we factor this? We can take an x out. Okay? And what's left is x squared plus 7x plus 10. Yeah, show a little bit of work. You don't have to show every step. Like copying the problem down, I don't count that as showing work. So, does this thing in parentheses factor in? Yeah. What multiplies into 10 that adds up to 7? 2 and 5. Okay, we don't need to use a rational root theorem on this one, but we will on the next one. 12 is, yeah.
Why are they gonna make the evens help?
One of the odds you have to do it. Okay, I'll do 12. Yeah, it's kind of, they're all a little bit different. That's the problem. They made them all a little bit unique. So what x values make this equal 0? Okay, you might have forgot this one. If there's an x out in front, 0 is one of the answers because 0 times all this equals 0. If you plug 0 up here, it makes it all equal 0. Okay. Yeah, there is a way to factor 12, but it really wasn't in this book, I don't think. Did we ever do grouping? I don't think so.
Are we gonna have any approximate irrational zeros?
What?
What's the question?
These are the zeros. Sometimes they're saying some of the answers are going to be like square roots,
Are we
and they, in that case, yes. In that case, they want you to change it to a decimal. I'm talking about like 13 and 14, square root answers. I lost my place. Minus 5x squared minus x plus 5. Okay, yeah, let's do rational root theorem on this one. So factors of, you guys remember how we did it? Factors of 5 over factors of 1. So what goes into 5? So it's 1 over 1 or 5 over 1. Okay, now how do we figure out if it works or not? When they say the zeros of the function, they mean the x values that make the function equal 0. So we need to plug this in and see, does 1, for example, make all these equal 0? Or does negative 1, or does 5, or negative 5? If you plug in 1, 1 cubed is 1, minus 5, minus 1. Okay, whoops. Is that equal 0? Yes. So instead of plugging the rest of them in, sometimes it wouldn't work, but I'm going to divide it out like we did yesterday. We're going to divide that answer out. Add down, multiply up, add down, multiply up, add down. Okay, this one's going to come out nice too, kind of like number 11, because this factors what multiplies into negative 5, that adds up to negative 4. Negative 5, positive 1. So what x values make these factors equal 0?
Negative 1, 5.
Okay, yeah. 5, negative 1, and we have to throw in the 1 from earlier that worked. Ava, are you getting it yet, or you still need some help?
I think I'm getting.
Huh?
I think I'm getting.
Okay. There are a lot of steps. It's just hard to kind of keep track of it all.
Is it possible they won't factor?
Yes. That's what I meant on 13 and 14. It's going to be square root answers. That means it doesn't factor. Okay, so 13. X cubed minus 7x. Well, okay, this one actually does factor for the first answer. Because what can we do on 13? Take an x out. Now, if we take an x out, what value for x will make this equal 0? 0. So 0 is one of the answers. The last two answers are in that. How do I make x squared minus 7 equal 0? Yeah, well, not yet. Okay, yes. Get the x squared by itself. Square root to get rid of that square. What'd I do wrong? Okay, and the direction said change it to a decimal. So somebody needs.
Have to?
Yes.
Did you run out of questions?
Yeah.
Well, let's just say, what did I do wrong? Did you plan that beforehand, or do you forget and say, oh, what did I do wrong?
Well, did you notice I say that like every time?
So maybe you
Yeah,
forget.
I planned it.
It's 2 points. I hope you know, I was actually laughing at 2 points.
Okay, it's we're rounding to the hundredths place, so it's 2.65. You do need to put positive or negative on that though.
What the heck?
cackle today.
Can you do 14 with us too?
Nah, it's the same thing.
It's not.
Yeah, you're right. You're gonna have to, after you take an x out, you're gonna have to use quadratic formula on the
That's
leftovers.
why I was so confused.
I was hoping so.
I could tell with the way you pause and every looking back over your shoulder. So funny.
I forgot what. No wait.
Okay, well, we'll just say 14's good. There,
We don't have to do 14?
no, we'll stop at 14. Yeah, you do have to do 14. We'll stop at 14.
Oh, okay.
You don't have to do 16 or 15.